In this topic, we're going to talk about two terms that describe how organisms and ecosystems can be affected by toxic pollution in their environment. So the two terms are bioaccumulation and biomagnification. And so when we talk about the first one, bioaccumulation, happens in an individual organism. That when an organism lives in an ecosystem that is polluted with certain toxins, they can absorb those chemicals into their body tissues over time. And they can absorb those toxins through respiration, through breathing. If we're talking about aquatic organisms, they can be taken up into the gills of the organism. Others come from their diet as they eat foods that have these toxins present. They ingest them. And often these things, if they're, for example, POPs, they are building up within the fatty tissue of this individual organism. So throughout its lifetime, it's absorbing more and more of these toxins, and their concentrations within its tissues is increasing. That's bioaccumulation. It's accumulating these toxins over an individual's lifetime. Another phenomenon that's important to understand is this concept of biomagnification. And in biomagnification, we're talking about not just one organism, we're talking about an entire food chain or food web. And so biomagnification is when organisms that are higher up the food chain, at higher trophic levels, tend to accumulate more of these toxins than organisms that are lower on the food chain. Each step up the food chain we go, we have increased concentrations of these toxins. And so, for example, if we look at this diagram on the right, okay, we have this is using PCBs as an example. PCBs being deposited through deposition, through runoff, into the water. The producers living in that water, for example, phytoplankton, they absorb and take up some of these toxins, these PCBs, into their tissue as they take in water. Okay. Some of that absorbs into these phytoplankton. And then at the next trophic level, these zooplankton, they eat many of these phytoplankton. So as they consume the phytoplankton, they're consuming a lot of them. So the concentration of PCBs is higher in these zooplankton. It's higher than it was in the phytoplankton. When herring eat many of these zooplankton, again, these toxins that are concentrated in their tissue then are absorbed by the herring. And so the concentration increases even more. And then the salmon who eat many herring, they are again absorbing many of these PCBs into their own tissue as they eat the herring. And then the top predators in the ecosystem, for example, this orca, as it eats the salmon, it is then ingesting all of these toxins as well. And so the concentrations are even higher. So biomagnification is as we move higher up a food chain, the concentration of these dangerous substances can get greater and greater. And it's these POPs that often have a tendency to accumulate. Heavy metals tend to accumulate in organisms. And the organisms that are at the top of these food chains, they are often the ones that experience the most profound effects of those organisms, that pollution. So for example, this is from data in which we're looking at DDT contamination in the water. If we look at the concentration of DDT in the tissues of these different organisms, what we see is, as we move higher up the food chain, much greater concentrations of this DDT. And DDT, as we've talked about before, DDT, the pesticide, was used extensively, but as it biomagnified, it had serious impacts on birds of prey, like osprey, like bald eagles, and things like that. The effect of DDT was the thinning of the shells of eggs when these birds were reproducing, making them extremely fragile and therefore less likely to be viable. This also is important for humans. So, for example, mercury levels in fish. So in some of the fish that people eat, things like shark or marlin, swordfish, these are fish that are at the very top of their food chain, very large fish. So because of these processes of bioaccumulation and biomagnification, those top of the food chain fish often can have higher levels of mercury. They can even have dangerous levels of mercury. And so oftentimes pregnant women are guided to limit their intake of certain types of fish and to avoid certain types of fish and eat limited amounts of others. And so we can see that graphic here, which shows, the fish that should be avoided by pregnant women, the ones that should only be eaten, once a week, and the ones that can be eaten 2 or 3 times a week. And that's, again, because of this process of biomagnification. Higher up the food chain, the more likely those fish are to have these toxins or heavy metals present in their tissue at high concentrations.